Alright, welcome to section 4.3, adding and subtracting polynomials. So here's a question. What is a term? When I'm talking about a term in math, what am I talking about? Well, basically a term is a single mathematical expression. So a single expression. So if you'll recall, there's that thing about expressions and equations, right? So an expression is just something like maybe 3xy, or maybe something like 2 over 5x, something like that. There's no equal sign in it, it's just sort of some math, little math things right there. The next question is, what is a polynomial? So a polynomial is combining terms. Combination of terms. And this is not the actual definition of the book. Make sure to read the section 4.3 in your book to get the actual definitions on these. Generically, though, a combination of terms, and basically, they're separated by a plus or minus sign. So, for example, 3xy plus 2 over 5x. So if I took the terms from above, if I took them, and then I just put an addition sign, I have created what we would call a polynomial. And this is a polynomial with two terms. Poly actually means many, like polytheistic means many gods. So poly means many, and nomial would mean like numbers. So polynomial means many numbers. Alright, let's take a look at example 1. Determine and state the type of polynomial and the degree. Rearrange the polynomial in descending power if possible. Alright, so let's go ahead and determine the type of polynomial. Well, first off, this is only one term. There's no plus or minus sign anywhere else, so this is a one-term polynomial. Another name for this would be a monomial. If you think of a monocle, right, that glasses that a person has, the single eyeball glasses on a person's face. So a monocle. So a one-term polynomial would be a monomial. Now the next thing to decide is the degree. How do we figure out the degree? We're going to look at the variables. In this case we only have 1, and then look at the highest degree, which would be 9. So degree 9. One-term polynomial, degree 9. It does say to rearrange the polynomial in descending powers, but since we only have one term, we don't need to rearrange, so we're done. Alright, so we've looked at monomials. Let's take a look at the next one. Ooh, I do see a plus sign. So we have two terms going on, the 4x squared and the 5x to the 6th power. So this is a two-term polynomial. And another name for this would be a binomial, where the word bi, if you recall, means two, like bicycle, two wheels. Alright, so we have two-term polynomial, also called a binomial, and what is the degree? Oh darn, we have two terms. So let's take a look at their variables. We have an x to the 2nd power and an x to the 6th power. What you do is you take the term that has the highest power, and that's your power. So the one with the highest power is going to be the x to the 6th power. So this is going to be degree 6. And rewriting this in descending power would mean we'll take the one with the highest power first. So that'll be 5x to the 6th plus 4x squared is descending power. Let's take a look at the next example. How many terms do we have here? Well, we have a plus and a plus. Okay, so we have three terms. 1, oops, highlighter. 1, 2, 3. So we have three-term polynomial. Oops, let me change my pen color. Three-term polynomial. And the name for this would be a trinomial. Like tri for a tricycle that has 3 wheels. So trinomial, and what is the degree? Ooh. Oh, this one's kind of weird. The 4 doesn't have a degree. We could think of a variable being to the 0 power. This one has degree 2, but this one has 2 variables. What is the degree of one with 2 variables? Now this one is weird. Really pay attention here. What is the degree with one that has 2 different variables? Well, you add up the degrees on the variables. So we have a 5 and a 1, because the y has degree 1. So this is going to be a 6. So this is going to be degree 6. Kind of weird, but that's how we count the degree. So degree 6. Now rewriting this in descending power, how do we write it if we have two different variables? Well, usually you'll just go alphabetically. Since x comes before y, I'll go ahead and stick with the x to the 5th, y, plus 2x squared plus 4x. We'll usually go descending in terms of the x values. Is descending. Alright, and D. Let's see, how many terms do we have here? Got all the different plus signs, and it can be minus signs as well. Sorry, I didn't put any minus. We have 1, 2, 3, 4 terms. Whoa! 4-term polynomial. Does this one have a nickname? No, it doesn't. So pretty much all the sort of shorthand or the specialized names, we have monomial, binomial, and trinomial, and after that we basically stop. From there on, we just state the number of terms. So 4-term polynomial, 5-term, and so on. So we have a 4-term polynomial, but what's the degree? Let's see, this is x to the 1 power, y to the 1, x to the 3rd, and y to the 2nd power. So which one has the highest power? That x to the 3rd. So this is going to be degree 3. And then in descending order, usually we'll go with alphabetically, so we'll choose x. So I'm going to rewrite it. This will be the first one because it's the highest power, 3x cubed, plus, then we'll do the next highest power, so that'll be 5y squared, plus next highest power, in between 3x and 6y. I'll go ahead and go alphabetically first, is the 3x and 6y. There is some difference in descending power for that. Usually, that's not that important in this course, at least in terms of different variables. Alright, so here's a question. What are like terms? Well, like terms are terms that have the same variable parts. Once again, this is a sort of a simplified definition. If you want the straight definition, please make sure to check for that when you are reading this section. So for example, if we had these different terms, are these all like terms? You might be tempted to say yes, because they all have x, y. However, when we're looking at the variable part, once again, we look at the variable part, not the number part when we're talking about like terms. We're trying to see if the variables are exactly the same. These two both have x to the first power and y to the first power. However, the middle one has y to the first power, but an x to the second power. So the like terms, these two are like terms, but this one is not a like term with the other ones. Alright, so you're going to look at the variable parts to determine if they are like terms. So simplify the following by combining the like terms. Alright, let's take a look at the variables. We have a b and a b, and then an a and an a. Okay, so I'm going to go ahead and rearrange these. I'll put them in parentheses. You don't need to use the parentheses. I just like to do that. 2a minus 4a. We rearrange them in terms of like terms, and then we'll do the subtractions. The 3b minus 3b, they cancel. We're left with 0b. We don't need to write that. And then 2a minus 4a is going to be a negative 2a. And we're done. Let's take a look at b. Like terms, we have y cubed, y cubed, y cubed. Ooh, and then an xy. That's the only one that's not a like term. So we'll go ahead and combine these. We have a negative 5 plus 8 minus 1. So negative 5 plus 8 minus 1. Let's do this on the side. Negative 5 plus 8 minus 1. That is going to be 3 minus 1, 2. So we have 2y cubed plus xy. And we're done. Let me go ahead and erase this. Alright, next. Let's see. So we have an x squared y for this term here. We have an xy squared. Okay, it's different. Oh, and then another xy. Alright, so these guys are like terms and the other ones are like terms. So go ahead, once again, I'm going to pair them up with their like terms. You don't have to do this step. I just like to do it to keep things a little more simplified. Alright, and then combining. So we have 5xy's minus 4xy's, or x squared y's. So that'll be just 1 x squared y plus, and then we have 3 xy squareds and 1 xy squared. That'll give me 4 xy squareds. Alright, so we practiced simplifying like terms. Let's go ahead and do as indicated for this example. The question is, what's being indicated? Well, we have this one polynomial here, and we're wanting to add to it another polynomial. There are different ways to do this. I like to just group them by like terms, as usual. So let's see what like terms we have. We have an a to the 5th and another a to the 5th. So I'm going to go ahead and pair up the a to the 5th values. So 3a to the 5th minus 8a to the 5th. Then I'll pair up the other ones. Let's see, what else do we have? We have a to the 3rd and a to the 3rd. So I have negative 9a to the 3rd plus 8a to the 3rd. Plus, I have a squared and, oh, I don't have another a squared. So that one, he's just by himself. The 4a squared does not have a like term. And then the 2 also does not have a like term. So those guys are basically done. Let's go ahead and combine the like terms in their groups. So we have 3a 5th and negative a to the 5th. So 3 minus 8 is going to be negative 5a to the 5th power plus, and then let's see, we have negative 9 plus a to the 3rd power. So that's actually going to be negative 1. So we had erase that plus. We have a negative a to the 3rd power plus 4a squared plus 2. And that is it. We've combined all the like terms. We can go ahead and box our answer. And notice it is in descending power. A to the 5th is first, then 3rd, 2nd, and so on. Alright, lastly, what do we have here? We have one polynomial, and we're subtracting from it another polynomial. Okay, so there are, as I said before, there are different ways to attempt these. But what I like to do with subtraction, because it can be a little difficult when we're working with negatives, I actually like to line them up in terms of their like terms. Now you have to be careful though. We're subtracting this one from that. We can't switch them around. So I'm going to go ahead and line up p to the 4th, p to the 3rd, and 5. And I'll go ahead and put subtraction on the bottom. If I need to leave a space for, let's say I had a p to the 2nd power on the top but not on the bottom, I would just leave a space and not do any subtraction for that. And then on the bottom we have the other one. Let me write that in yellow. 3p to the 4th plus 5p cubed plus 2. And we're doing some subtraction. So what do we have? We have p to the 4th minus 3p to the 4th. So that'll be negative 2p to the 4th. And then we have p to the 3rd power minus 5p to the 3rd power. So subtracting 5p, that's p to the 3rd minus 5p to the 3rd, that'll be negative 4p to the 3rd. And lastly, 5 minus 2. 5 minus 2 is going to be 3 plus 3. Okay, so that was one way we could do the subtraction, which I find some students find that helpful. And if this way wasn't that helpful, you could go ahead and just group them by like terms. So you could do p to the 4th minus 3p to the 4th. You have to remember we have that minus to deal with. And then you could do plus p to the 3rd minus 5p to the 3rd plus 5 minus 2. You could also do it that way and you would get the same answer. There are two different ways to work with it. Alright, that is it for this section. If you have any questions, please drop by my office hour or send me an email and set up another time to meet.